guys, welcome back to another IM2 video. So in this video, we're actually going to be going over some review. So this means I just picked out a couple questions from previous units and previous videos that we have done in the past, and we're going to do them in this video. I am doing a review video just because I know EOCs are coming up and you guys want to make sure, well, I want to make sure you guys are feeling prepared. So the first question that we're going to be going over are how to write recursive equations and determine the kind of function. So first, we're going to figure out the function type. Now, the way we're going to do that is we're going to look at the table values that we have. We're going to look at both the x and the y values. So first, we can see here that every value on the x is going up by 1, right? Plus 1, plus 1, plus 1, and so on, okay? Now, on the y values, we can see we're going up 4, then 2, then 4. Wait, is that right? Hold on, guys, I'm lying to you. Okay, I just lied to you guys. So here on the y value, we are going down 4, then we are going down 2, then we're going down 0, then we're going back up 2, back up 4, and back up 6. So there's definitely not a common first difference. Let's see if there's a common second difference. So there is a difference of 2 right here. Minus 2, 2, 2, 2. Okay, we can see that there is a common difference of 2 values, and we have a common second difference, then we know our function is quadratic, right? Because if it were to have a common first difference, it would be linear. So we can go ahead and label this function as quadratic, and if we want to list the reasoning, or like we want to give the reasoning, because there is a constant second difference in the y values slash outputs, right? Because the x is the input and the y values are what we get out. Now let's write our recursive equation. So just as a refresher, actually can I ignore all that? Okay, just as a refresher of recursive equations, we're gonna go over here. We use f of n, and what f of n just means is like whatever number we input at this time, if that makes sense. So let's say we put in the first term or the second term, right? This represents our term number. Just a quick refresher. So for this recursive equation, we're going to start off with f of n is equal to f of n minus 1. And f of n minus 1 is just previous term, right? And then we also know that since there's a common second difference, we're going to be multiplying by some value, right? Okay, we know we're also going to have plus n, but we don't know what we're multiplying with, right? Since there's a common second difference, we know there has to be some sort of multiplication here, but we don't know what value. So we're going to go back and we're going to look. We said there's a common second difference with the value of 2, okay? So that is a number that we're going to plug in over here. Now, I know I did that like pretty quick, but let me go ahead and simplify this back down. So what I'm trying to do with the recursive equation is I'm trying to find an equation that is going to let me find or let me solve for any term, right? So if I wanted the second term, I'm going to use the previous term, so the term before the second term, which is the first term, right? Plus 2 times my current term, or the term that I'm trying to find. If that's a little confusing, let me plug some values in. Okay, so let's say we have f of 2, right? is equal to f of 2 minus 1 plus 2 times 2. Now the reason like I'm using 2 is just because it's like simple, but I'm plugging in 2 for every n because that is the term number that I'm going to use. That is our number term, right? This is the second term. So we plug that in for every n. Now, I can actually go back on the table and check it out. So I can see that when my term number is 2, I get out 4. So let's see if my equation works. Okay, so this should be 4, right? We solved that. We didn't solve that. We saw it on the table. Okay, so f of 2 minus 1, that becomes f of 2. That's not f of 2. I lied to you guys. That becomes f of 1 plus 2 times 2, that's 4. Okay, what is f of 1? We're going to go back and look at the table. F of 1 is 0, right? We can see this right here. F of 1 is 0, so this is just going to become 0 plus 4 equal to 4. 4 equals 4. Yep, that checks out. So we can actually do that with another value. Let's do f of negative 2. Okay, so we have f of negative 2 is equal to f of negative 2 minus 1 plus 2 of negative 2. Okay, that looks really bad. Anyways, what is f of negative 2 here? Okay, the table says that f of negative 2 should be 0. Let's see if our equation holds up. So f of negative 2 minus 1, that's negative 3, plus 2 times negative 2, that's negative 4. Let's see what f of negative 3 is. F of negative 3 is 4. Okay. So this becomes 4 plus negative 4. Adding a negative is the same thing as subtracting, so that just becomes 4 minus 4, which is 0. And yep, that checks out. So that is a review of our recursive equations and just labeling function types. Just because I didn't review it in this table, let me remind you guys that if we have a constant ratio in the differences, it's exponential. So for example, if I had 1 and then 2 and then 4 and then 8, our common difference is that we're multiplying by 2. There's a constant ratio, remember that, constant ratio of 2, which just means it's being multiplied by 2. Okay, now that we're done with that, we're gonna go on to distributing. So we're gonna be reviewing some distributing. So here we have an equation, negative 5 times x minus 4. So what we're gonna do first is we're gonna distribute this negative 5 to everything. So negative 5 to x becomes negative 5x. Negative 5 to negative 4. A negative times a negative is a positive, so that becomes plus, wait, let me do the 5, 10, 15, 20. Okay, plus 20. Yes. And that's it. That's literally it. That's we distributed it as much as we could. It was pretty simple, right, guys? Right? I'm thinking so. Just remember, as we get like onto more complicated ones, keep track of what you've distributed and what you haven't. I like to do the arrows because it really helps me keep track of everything. Okay, then we have 7x times x minus 1. Okay, so here we're going to be distributing our 7x to our x and our 7x to negative 1. Now, here's one thing that I want to make sure you guys remember. If we multiply an x by an x, it becomes x squared, right? So don't let that trip you guys up. So instead of this just becoming like 7x, it's become 7x squared, okay? Because it's an x times an x, we're multiplying something by itself, right? If we did 2 times 2, that could also be written as 2 squared, or 4 times 4, that's 4 squared, right? Okay. Then we're going to distribute the 7x to the negative 1, and it's just become negative 7x. Bam! Look at that. Really, the main things with this is just make sure, or like try your best not to get these things mixed up. And I feel like for me, using the arrows is the best way to do that. Okay, now, last one for distributing. We're going to do negative 2x times 3x plus 1. So once again, remember x times x is x squared, or if we had x squared times x, that becomes x cubed. Or if we had x to the 4th times x, that's x to the 5th. Do you guys see the pattern? Yeah. Okay, so we're going to do negative 2x times 3x. That becomes negative 6x squared. Just because, oh shoot, oh my goodness. Okay, there we go. The reason it becomes a negative 6x squared is because we have the negative 2 times the 3. That's where we get the negative 6. And then the x times the x is x squared. Now, if we do negative 2x times 1, that just becomes plus negative 2x. I like to do with the pluses, but it could also be written as negative 6x squared. Oh, I keep doing it. Minus 2x. Bam. That is all for distributing, guys. The main thing is make sure you don't get tripped up on these x times x rules, the x squareds, and make sure you keep track of what you've distributed and what you haven't. Now, on to our last section is identifying key features of functions. So, here we have a quadratic function, and we are asked to find the vertex, the domain, and the range. So the way we're going to do that is first, this is actually in vertex form, so that makes it a lot easier. Our vertex is going to be 5, negative 6. Now, if you guys remember, our vertex is these two values, right? The only thing is that whatever numbers in here, you see how it says negative 5, it's going to be the opposite. So it's just going to be 5, negative 6. This value on the outside stays exactly how it is. This number on the inside is the opposite. So our vertex is 5, negative 6. Now, our domain is actually all real numbers or negative infinity to positive infinity. And the reason for that is because we can see that it's a quadratic, and we know it's a quadratic because it has this, it's squared. And let me do a little visual. If we have a quadratic, right, it's gonna make either this shape or this shape. And the further the arrows go, the more spread out and the more it's gonna reach across the x-axis, right? You see how it's just like continuously going outwards? That is why with quadratic functions, our domain is all real numbers because it continues to grow horizontally, like across the x-axis. Okay, now range is not all real numbers. And the thing with range is you can actually find this really easily if you find your vertex. So we know, well, firstly, okay, if we have a graph, we can see that our vertex is at 5, negative 6. So it could be somewhere like over here, right? 5, negative 6. Now, if we look at our function, we can see that our leading coefficient is actually negative. Since our leading coefficient is negative, we know it's going to be open up downwards, right? So we know it's going to look something like this, since we're opening down. If our leading coefficient were positive, we would be going upwards. But since it's negative, we're going downwards. Now, as you guys can see, our range is going to be everything from here on downwards. We are never going to go above, like we're never going to go over here or above our vertex point. So, majority of the time, actually this is the case for all of the quadratic functions, unless you have obviously like a domain or restricted domain or something like that, is that your vertex point is either going to be, like the y value corresponding with your vertex is either going to be your maximum or your minimum. In this case, since our leading coefficient was negative and the function is opening downwards, the y value that corresponds with our vertex is going to be our maximum, because our function is not going to get any more, it's not going to like get any bigger on the y-axis because it's only going downwards, if that makes sense. So our range is actually going to be y is greater than or equal to 6, right? All that's saying, I literally just lied to you. I just blatantly lied. I'm so sorry, guys. Y is going to be less than or equal to -6, right? All of our y values in this range are going to be less than -6. And the reason I say less than or equal to is because we actually do end up on -6. Like, our vertex point is on there, so we're going to label that as one of our points. Yeah, the main thing to remember with the range is that you have to look at both your vertex and your leading coefficients to see if our y value for that vertex is going to be our maximum or our minimum. Okay guys, that is it for this video's IM2 review. I hope you guys had a great time. I hope you enjoyed that video. Please, if there's any specific topics you want us to go over, make sure to leave those in the comments. Or if you would like any help prepping for your EOCs, don't forget to request some tutoring from Mu Alpha Theta. Thank you guys. Have a wonderful day.